today, for the second part of the video, we're going to talk about what to do with negative exponents and how to deal with fractions with negative exponents. If you're in my class, we are on page 5 of the exponent rulebook. So to make negative exponents into a positive exponent, you have to move them, because basically what they are is the inverses. So x to the negative second is actually the same thing as saying 1 over x to the second. Now sometimes you'll have two negative exponents. In that case, you have to move them both. So for example, c to the negative second would be 1 over c to the second, so that's why the c to the second is in the denominator. D to the negative third is actually in the denominator, so it's going to move to the numerator. So the easiest way to think about this more in general is you want to move the fractions or the exponents to make them happy. So if you look at my third example here, I have a to the negative third over b. A to the negative third is unhappy on the top, so what we do is we move it to the denominator. Now the b has no negative exponents, just b to the first. So we just leave it there. Now, since everything is in the denominator, though, we do need a numerator. So that's why I put 1 in there. So we're going to make some things happy. So for example, I'm starting to combine all my different rules. So a lot of times when you're dealing with these, what you want to do is deal with the basic properties first and then deal with making the exponents positive or negative. So if you look at this is a multiplying problem. So just like before, I'm multiplying, we multiply the numbers and we add the exponents. So 4 times 5 is 20. X's, I'm going to add x to the negative third, and x to the negative ninth is x to the negative 12th. Y to the 7th, and one more y is y to the 8th. Now we're not quite done yet because we don't want any negative exponents. So the 20 is not a negative exponent, so it just remains where it is. Now what is negative is this negative 12. So what we're going to do is we're going to move that x to the negative 12th to the denominator. So my new problem becomes 20. The x moving to the bottom becomes x to the positive 12th. And the y to the 8th, since it's already a positive exponent, remains in the numerator. So each piece, each term, or each variable is counted as a separate piece. Let's look at another one. So once again, we're going to multiply the numbers. It's negative 8 times, wait, there's nothing here. But there is. Remember, if there is no coefficient, the coefficient's a 1. So negative 8 times 1 is negative 8. Okay, I have A's, B's, and C's this time. So I'm going to deal with my A's first. A to the 10th and a to the negative 4th. Same base, we add the exponents. 10 plus negative 4 is 6. B's. B to negative 11th and b to the 2nd, when added, gives me b to the negative 9th. And C's. 1c and 1c makes c squared. Now, negative 8 is negative, but it's not a negative exponent, so it's not going to move. The only thing that's going to move in this case is the b's because they're unhappy on top. So we have negative 8, or you can put the negative in front. A to the 6th. B to the 9th is going to go on the bottom, and c to the 2nd, since it already has a positive exponent, is going to remain in the numerator. So negative numbers do not move, only negative exponents. Let's take a look at a couple power to a power problems. So 7x to the negative 2nd, y to the 8th, all to the negative 3rd. Now there is multiple ways of doing this problem. I'm just going to show you one way. Now everybody's going to get the negative 3rd power. So that 7 is actually going to be 7 to the negative 3rd. X, negative 2 times negative 3 is positive 6. And 8 times negative 3 is negative 24. Now, unlike last problems, we actually have two values that have negative exponents. The 7 and the y. So 7 to the third is going to go in the denominator, and 7 to the third in our calculator is 343. X to the 6 has a positive exponent, so it's going to stay in the numerator. And y to the negative 24th is going to move to the denominator and become a positive 24. Let's take a look at another one. Negative 2, 8b to the negative 5th, all to the negative 9th power. So everybody's going to get the exponents. So negative 2 is going to get the negative 9th power. A is going to get the negative 9th power. And B, negative 9 times negative 5 is a positive 45. We're going to decide who needs to go to the denominator. Well, the negative 2 does. The A to the negative 9th does. So my B to the 45th is going to remain in my numerator. A to the negative 9th is now going to be A to the positive 9th. And now I got to figure out what negative 2 to the 9th is. Negative 2 to the 9th is negative 512. So notice when I moved to the bottom on this one, it became negative 2 in parentheses to the 9th power, which is negative 512. And I put the negative out in front because we don't normally leave the negative in the denominator. Okay, let's combine a couple more. So the first one. A to x to the negative third, y to the 5th, times negative 2, x to the 9th, y to the 3rd. So step 1, I need to do the second set of parentheses. So I'm going to take negative 2, x to the 9th, y to the 3rd, all to the 3rd, and I'm going to go ahead and combine those. So negative 2 to the 3rd is negative 8. Power to a power, we multiply. So 3 times 9 is 27. Y to the 3rd. Now we have the same base, so we're going to add the exponents. We multiply the numbers first. 8 times negative 8 is negative 74, or 64. Negative 3 plus 27 is 24. And 5 plus 3 is 8, and we are completing that problem. Let's take a look at the next one. So first of all, I'll notice here I've got a problem. And here I've got a problem. So I need to do those each separately before I start. So power to a power, I multiply. 5 times 7 is 35, so a to the 35th. 4 times 7 is 28. That gives me my first set. Now I do my second set, same way. 6 times negative 2 is negative 12. Negative 2 times 1 is negative 2. And c to the 4th. Now, this is like the problems we did earlier. So what we're going to do is we're going to go ahead and combine them before we move them and see if we have anything negative. So a to the 35th plus negative 12. Oh, there's my error there. Okay, a to the 35th is really like a to the 12th over a to the 35th over a to the 12th. Now, if this makes sense to you, do it this way. Make everybody happy first. But I tend not to do it that way. What I do is I add my exponents. 35 plus negative 12, 28 and 4. When I do so, I get 35 and negative 12, which is 23. 28 and negative 2, which is 26. And then I can't forget that c to the 4th that is still hanging out there. So you can move things to the bottom before you start, or you can just wait and simplify them afterwards. Let's look at a couple with division, more complex ones. This is power to a power, but in this problem, what we have is we have some major division and powers going on. So first thing I do is I simplify what's inside. 5 over 25 is 1/5. X to the 9th over x to the 3rd. There's 6 more x's in the numerator than the denominator. Y over y to the 7th, there's a little right-o. it should be y to the 5th. And then from there, what I do is I give everybody the power. 1 to the second, y to the 6th to the second is 12. 5 to the second, and then that should be 5 times 2, so that should be y to the 10th. 1 squared is 1, so that becomes 1x to the 12th, or just x to the 12th. 5 squared is 25, and then we have y to the 10th. Let's take a look at another one. So I'm going to do the same process. I'm going to start by simplifying. Now, notice the only number in there is a 4, so I can't really do anything with that. My a's are in the top, so we're good. Now, the b's, 13 b's in the numerator are unhappy in the numerator, so they're actually going to have to go to the denominator and get added to what already exists there. So once I do so, the a to the negative a to the 11th, and the b becomes b to the 16th. Now the c's are the same power, so what happens is those lovely little guys cancel each other out. So that makes it nice. We don't even have to deal with the c's. From there, we take -1. Here's my negative. Right there. -1 to the 4th, we get +1. That's that. A to the 11th is 44, and that's where we get a to the 44. Now the bottom, 4, both of them get the 4th power. So 4 to the 4th is 256, and 16 times 4 is 64. Now we're almost done. We only have a couple left to go. To finish off today, we're going to look at what do I do if I have a negative exponent on the outside. Now you have a couple options here. You can simplify what's inside. You can distribute the negative power, but we're going to kind of keep this kind of simple. So step 1, what I'm going to do is I'm going to release it or show it to you. I reduced it. So I said 24 over 26 is 12 over 13. I had 6 a's on top, so they came down. My b to the negative second was unhappy on top, so it's going to move the bottom. So 2 combined with 3 more gives me 5. My c to the negative 4th is unhappy on the bottom, so we move it to the top. Since there's 1 right here, it becomes 4 plus 1, which is 5. Okay, from there, I did a little math. Now, this says the inverse. So what that means is it's the inverse of everything. So you could distribute a negative 3rd power around to everybody and move everybody. Or if you notice from here to here, all I had to do was I carried the whole problem. I just took the reciprocal of it. By taking the reciprocal of it, I was able to change it to a positive 3rd power. Now, since it's a positive 3rd power, everybody just gets the 3rd power. 13 to the 3rd is 2,197. 5 times 3 is 15. 12 to the 3rd is 1728. 6 to the 3rd is 18, because it's power to a power. And 5 to the 3rd, 5 times 3 is 15. Now, the great thing about this is a lot of times when you simplify beforehand, there is no simplifying to do later on. So that is my final answer. Let's take a look at one more. So just like before, I'm going to simplify all the values inside. I look and I say, hey, I have more x's on the bottom. How many more? Well, I have 1. Wait, I forgot my 1. It looks like on that one I made a major goof. So I'm just going to redo this entire problem for you. Let me change up a couple things. Okay, so let's look at this last problem. So step 1, I'm going to reduce what's inside just like I said. The 3 is in the denominator. I have 7 x's on top and 8 x's on the bottom, so I have 1 more x in the denominator. Y's, well, my y to the negative second is unhappy on top, so if I imagine it, it's going to go to the bottom. Y to the 7th wasn't happy on the bottom, so it's going to go to the top. So where do I have more y's at? The numerator. Y to the 5th. Now I'm going to take it all to the negative fifth power. So to do that, I take the reciprocal, and what that does is it changes my power from being a negative 5 to a positive 5 now. So now everybody gets the fifth power. So 3 to the fifth power, 3 to the fifth power is 243. X gets a fifth power. And this already has a power, so it's power to a power, so we multiply. 5 times 5 is 25. I hope this video has been helpful. Now you're going to try a few on your own.